Welcome to Exercise Set 5. This session will focus on two fundamental pillars of object-oriented programming, inheritance and polymorphism. We'll see how to create hierarchies of classes where child classes inherit properties and behaviors from parent classes, and how polymorphism allows us to treat objects of different classes in a uniform way through a common interface. Our first problem asks us to create a simple application, letter demo, involving two classes, letter and certified letter. The context is a company tracking mail. The letter class is the base class. It needs to keep track of the recipient's name and the date mailed. These should be implemented using auto-implemented properties, OOP principle illustrated, classes, properties, encapsulation. This defines the basic object structure and encapsulates its data. The letter class also needs a toString method that overrides the one inherited from the object class. This method should return a string including the class name using getType and the letter's data, name and date. Method overriding polymorphism. Overriding toString is a classic example of polymorphism, giving a base method new behavior in our custom class. The certified letter class is specified as a child class of letter. This is the core of inheritance. A certified letter is a type of letter, so it will inherit the characteristics and behaviors of a letter. The certified letter needs an additional auto-implemented property for a tracking number, which is unique to certified letters. Finally, the letter demo application class will create objects of both types and demonstrate their methods. Here is the code for our base class, letter, class definition properties. Define the letter class with public auto-implemented properties name and date. Constructors, a default constructor and a parameterized constructor to initialize the properties. ToString method, we have public override string toString. Polymorphism. The override keyword tells the compiler that we are providing a specific implementation of the toString method that our letter class inherited from the object class. This is polymorphism in action. When toString is called on a letter object, this version will be executed. GetType. Inside the method, getType is used to dynamically get the name of the actual type of the object, which is useful here for reporting. The method formats the output string including the recipient's name and the date. Now let's look at the certified letter class code. Inheritance, internal class certified letter : letter. The colon followed by letter is how we declare that certified letter inherits from letter. This means certified letter automatically gains the public and protected members of letter, including the name and date properties and the toString method. New property. Add a new property, tracking number, which is specific to certified letters. Constructors. The parameterized constructor takes the tracking number, name, and date. Note, the provided code directly assigns name and date here. A more typical pattern when inheriting would be to use base, name, date in the constructor's initializer list to call the base class constructor and avoid duplicating initialization logic. ToString method overriding again, another public override string toString. Since certified letter inherited a toString method from letter, we can again override it to provide a version specific to certified letter. This version includes the class name, getType, the inherited data, name, date, and its own unique data, tracking number. When toString is called on a certified letter object, this version will be executed. Finally, this shows the letter demo application, instantiation. For the certified letter object, the toString from the certified letter class is executed. The program treats both objects uniformly through the common toString method, but the specific implementation is determined by the object's type at runtime. Problem 2. The photo demo provides a more complex scenario involving inheritance. We need an application photo demo and three classes, photo, matted photo, and framed photo, representing a hierarchy for a photo development company. Photo is the base class. It includes fields and properties for width and height. It has a protected price field. Access modifiers, encapsulation. Protected members are accessible within the class itself and by any derived classes, but not by unrelated code outside the class. This allows derived classes to interact with the base class's internal state in a controlled way. The price calculation is based on dimensions, a specific price for 8 by 10 and 10 by 12, and a different price for any other custom size. The price property should be read-only, get but no set, abstraction. The price calculation logic is internal to the class, and the price itself is read-only, protecting its integrity. Photo also needs a toString override including class name and field values, method overriding, polymorphism. Another opportunity to customize the string representation. Matted photo and framed photo are specified as subclasses, derived classes, of photo. They inherit from photo and add their own unique characteristics. Matted photo adds a field for color. Framed photo adds fields for frame material and style. These subclasses increase the base photo price by a specific premium, $10 for matted, $25 for framed. Extending base class behavior. Derived classes can build upon the base class's data and logic, adding their own. Each subclass must include a toString method that overrides the parent class version. We'll see multiple levels of overriding the toString method in this hierarchy. Here is the code for the base photo class. Fields constants. Define private fields for width and height, the protected price field, and private constants for standard sizes and prices. Properties. Define public properties width and height. Notice that their set accessors call a method setPrice0. This means whenever the dimensions are set, the base price is calculated. Define the public read-only price property getOnly. Properties control access to fields, and the price calculation logic is abstracted away in a separate method called by the setters. SetPrice method, abstraction. This method calculates the base price based on the photo dimensions. It's marked protected, so it's accessible by matted photo and framed photo. It takes a premium parameter and adds it to the base price. Derived classes will use this to add their specific costs. ToString method. This overrides the ToString method from object. It includes the class type, dimensions, and the calculated price. Now the matted photo class, inheritance. Matted photo inherits from photo, gaining its properties, width, height, price, the protected price field, and the protected setPrice method. New field property constant. Add a private color field, a public color property, and a premium constant specific to matted photos. ToString method, overriding and base call. Show the public override string ToString. It overrides the ToString method inherited from photo. Base.setPrice premium is important. It explicitly calls the protected setPrice method defined in the base class, photo, passing the matted photo's specific premium of $10. This updates the inherited protected price field in the base portion of the matted photo object, incorporating the matting cost into the total price calculated by the base class's logic. The ToString method then formats the output including the class type, color, and the price, which now includes the matting premium. Framed photo class, also deriving from photo, inheritance, internal class framed photo : photo. Framed photo inherits from photo, similar to matted photo. New fields, properties, constant. Add a premium constant and private fields, public properties for material and style. ToString method, overriding and base call. The public overrides string ToString. Polymorphism, it overrides the ToString method, providing a specific format for framed photos. Calling base class logic base.setPrice premium calls the protected setPrice method from the base photo class, passing the framed photo's premium of $25. This updates the inherited protected price field. The ToString output includes the class type, style, material, and the total price incorporating the frame premium. Finally, PhotoDemo application's main method, demonstrating our class hierarchy. In this exercise, we explored inheritance by creating certified letter, matted photo, and framed photo classes that inherit from letter and photo. We saw how derived classes get members from their base classes and can add their own. We also significantly demonstrated polymorphism through method overriding, specifically by overriding the toString method in derived classes to customize their string representation. Additionally, we touched upon access modifiers like protected to control visibility within the inheritance hierarchy and how derived classes can call base class methods using base. These principles are essential for building organized, reusable, and flexible object-oriented systems. Thank you for watching.